For the application of the laws of sines and cosines. Okay, so let's have problem number one. An airplane A is flying directly toward the airport, which is 20 miles away. The pilot notices airplane B 45 degrees to his right. Airplane B is also flying directly toward the airport. The pilot of airplane B calculates the airplane A is 50 degrees to his left. How far is airplane B from the airport? So from this, let's say we have the airplane A and its distance through the airport, which is 20 miles away. Okay, so this is airplane A, and this is the airport. Okay, they are 20 miles away. Okay, and also the pilot notices airplane B 45 degrees to his right. So let's say we have this as our airplane B. Okay, and it measures 45 degrees. Okay, so airplane B is also flying directly toward the airport. The pilot of airplane B calculates the airplane A, which is 50 degrees to his left. So if, we'll have that. That is 50 degrees. So now the question is, how far is airplane B from the airport? So notice here that we have angle side. Okay, we have two sides here and two angles here and one side. Okay, so from that we can use the law of sines. Okay, so given that we have angle sides or side angle. Okay, so let's identify the airplane B. How far airplane B to the airport? Okay, so here we can use sine A over A and sine B over B. Okay, since provided that we have here angle A and angle B and side B. So with that, in order to identify the length of the BC, we can have this sine A over BC, which is this one, okay, is equal to sine B all over AC, over AC, okay, which is this one. Okay, so as we substitute the given, okay, we have here sine A as 45 degrees, and then we have here the sine B as 50 degrees, and then the length of AC, which is 20 miles. So as we substitute that, let's compute for the value of BC. So if you will use your calculator, you'll obtain 18.46 miles. So how far is a airplane B from the airport? And that is 18.46 miles. Another problem. A and B are 2 points on opposite banks of a river. From A, line AC is equal to 275 meters, is laid off, and angles CAB is equal to 125 degrees 40 minutes, and angle ACB is equal to 48 degrees 50 minutes are measured. Find the length of AB. Okay, so given that we have 2 points A and B, okay, we also have the line AC. Okay, from A, we have line AC, which is 275 meters, its length. So given that this is the line AC, that is 275 meters. And given that the angles CAB is 125 degrees 40 minutes, that is this one, angle A. And angle ACB, or the angle C, is 48 degrees 50 minutes. Okay, we need to identify the length or the distance of A to B. So as you can see here, as you notice, this is angle side angle. Okay, this is angle side angle. So given that this is angle side angle, we can use um, the sine law. Okay, the law of sines. So first off, we need to identify first the uh, angle B. Okay, so in order to identify the angle B, all we need to do is to add the angle A and C, and then subtract 180 degrees to its sum. Okay, and that is 5 degrees 30 minutes. So in order to obtain the length of AB, we need to use the sine B over B is equal to sine C over C, wherein side B is AC, which is 275 meters. And then we need to identify the AB, okay, which is the side C. So let's use that formula. Manipulating that, we'll obtain here AB is equal to AC sine C is equal over sine B. So substituting the given, we'll have 275 sine 48 degrees for 50 minutes all over sine 5 degrees 30 minutes. So if we will calculate that, use your calculator. AB is equal to 2,159.92 meters. So the distance from A to B, the length of AB is equal to 2,159.92 meters. Another problem. Okay, two ships leave a harbor at the same time, traveling on courses that have an angle of 140 degrees between them. If the first ship travels of 26 miles per hour and the second ship travels of 34 miles per hour, how far apart are the two ships after 3 hours? So given that we have two ships, let's say ship A and the ship B. Okay, we need to identify its distance given that uh, they are traveling on the same course that forms a 140-degree angle. Okay, let's say that is C. Okay, that forms a 143-degree angle. So as you can see here, we have an obtuse triangle. Given the fact that ship A travels 26 miles per hour, so if we will solve that, since we are after 3 hours, so let's multiply that to 3. The result of that is 78 miles. And then next one, for the ship B, it travels 34 miles per hour. If we multiply it by 3, the result of that is 102 miles. Okay, given that we have here a side angle and side, then we can use the law of cosines. Okay, so let's identify the distance between the ship A and the ship B. Okay, so for us to identify the distance of ship A and ship B, we need to have the C. Okay, the side C here. Okay, so C squared is equal to A squared plus B squared minus 2AB cosine C. So let's try to substitute. So as you can see here, we have the A squared as 102 squared, which is the length of BC, and the length of AC is the B squared, or the B. So as we substitute that, we'll have this 102 squared plus 78 squared minus 2 times 102 times 78 cosine 140 degrees. So again, remember this is in square. So you need to square root to obtain the distance between the ship A and the ship B. So solving for the length of AB, that is 169.34 miles. Okay, for the last problem, a yacht starts from a point A and sails on a bearing of 38 degrees for 3,000 meters. It then alters its course to a bearing of 318 degrees. And after sailing for 3,300 meters, it reaches a point B. So the question now is, find the distance AB to the nearest meter. Okay, so we will round off it to the nearest whole number. Okay, and then for the problem B, find the bearing of B from A to the nearest degree. Okay, so let's illustrate this first. So given that we have here a yacht which starts from point A with a bearing of 38 degrees. So if we will use that, we'll have here the degree of 38 degrees. Okay, and it travels 3,000 meters. Okay, that is we start at point A. And then it alters its course to a bearing of 318 degrees. Okay, after sailing for 3,300 meters. So let's set up this again. Its bearing. So as you can see here, its bearing is 318 degrees. Okay, and it travels 3,300 meters. Okay, which is it ends up with the point B. Okay, it ends up with the point B. Okay, so let's say this is the point C. Now, as you can see, we need to identify the distance between the A and B. Okay, we need to identify the distance between the A and B. Okay, but before that, let's just explore this. Okay, so given that this is an alternate interior angles, this one is 38 degrees. This one is 180 degrees. This is 38 degrees. And then this bearing is 318 degrees, right? So if we will look at this as a whole, this angle is equal to 360 degrees minus 318 degrees. Okay, and 360 minus 318 is 42 degrees. Okay, so given that this is 180 degrees, this is 38 degrees, and this is 42 degrees. So we know that the total of this should be 180 degrees. Okay, this forms a straight angle. So 38 degrees plus 42 degrees, that is 80 degrees. So 180 degrees minus 80 degrees is 100 degrees. So this one is 100 degrees. So given that we are going to identify the length of AB, let's use the side angle side here. Okay, we have here the side, we have the angle, and then we have the side. Okay, so since this is side angle side, we will use the cosine law. Okay, we will use the cosine law for this. So to identify for the AB, which is the side C, right? This is the side C. So if we will use the formula, C squared is equal to A squared plus B squared minus 2AB cosine C. And we know that the side A is the BC, the side B is the AC. Okay, so let's replace that and substitute. Okay, that is 3,300 squared plus 3,000 squared minus 2 times 3,300 times 3,000 times cosine 100. So again, this is cosine law. This is squared on the left hand side. So make sure you use the square root for this. As you calculate for this, you'll obtain 4,830 meters. So we round off it to the nearest meter. Okay, so we round off it in whole number. Okay, that is 4,830 meters. And then the for bearing of B from A. So bearing of B from A, we need to identify this. Okay, B from A. So from A to B. Okay, the bearing A to B. Okay, so as you can see here, it's almost 360 degrees. But we don't know this part, the degree of this part. And we need to subtract that. Okay, we need to subtract that. So in order to subtract that, we need to identify the angle A. Okay, since this is 38 degrees, and we don't know the remaining angle here to subtract, let's identify first angle A. So in order for us to have the angle A, since we have the side here of 4,830, and we have 3,300 here, and identifying this angle A. And then we have angle which is 100 degrees. So this is side angle. So let's use the law of sines. Okay, let's use the law of sines. Okay, this is the side angle. Okay, so in order to obtain this, we need to find the A, angle A, as sine A over BC is equal to sine C over AB. Okay, so BC here is the side A. Okay, this is this one. And then sine C over AB, and our AB is this one. Okay, which is the total of 4,830 meters. So let's use that. Okay, which is the side C. So manipulating this, we'll obtain BC is times sine C all over AB. And then substituting the given, we'll obtain 3,300 times sine 100 degrees all over 4,830. So since we are after with the angle A, so let's have the inverse, the sine inverse of 3,300 times the sine 100 degrees all over 4,830. And with that, we'll obtain 42.29 degrees. For the bearing of B from A, we can now subtract this angle A to this 38 degrees. Okay, then we can identify now the bearing. Okay, so for bearing of B from A, all we need to do is to subtract 42.29 degrees to 38 degrees. Okay, to subtract it to overall, which is 360 degrees. Okay, so 360 degrees minus the angle A, which is 42.29 degrees, minus the 38 degrees. Okay, let's just to know this portion, this angle. Okay, and subtracting that, we'll obtain 355.71 degrees. Or if we round off it to the nearest degree, that is 356 degrees.